Good morning, everyone. How are you all? I hope you all are good. Children, in the last session, we had discussed about heat. Heat is a form of energy. The degree of hotness is called temperature. We use a device to measure the temperature. It's called thermometer. Then we had seen two types of thermometer, clinical thermometer and laboratory thermometer. The topic for today's session is transfer of heat. What is heat? Heat is a form of energy. Now in this session we are going to learn about how does it transfer, right? You might have observed that a frying pan becomes hot when kept on a flame. Why does it happen? It is because the heat passes from the flame to the utensils. When the pan is removed from the fire, what happens? It slowly cools down. Why does it cool down? The heat is transferred from the pan to the surroundings. So you can understand that in both cases, the heat flows from a hotter object to a colder object. In fact, in all cases, heat flows from a hotter object to a colder object. Now, how does heat flow? Let us investigate. For that, we will do a small activity. For this activity, take a rod or flat strip of a metal, say of aluminium or iron. Fix a few small wax pieces on the rod. These pieces should be at nearly equal distances. Clamp the rod to a stand as is shown in the figure on your screen. If you do not find a stand, you can put one end of the rod in between bricks. Now heat the other end of the rod and observe what will happen. What happens to the wax pieces? Do these pieces begin to fall? Which piece falls the first? You will observe that the wax pieces which is closest or nearest to the flame will begin to fall first, then next, so on. Why does it happen? Have you thought of this? What do you think? Because the heat is transferred from the end nearest to the flame to the other end. Children, the process by which heat is transferred from the hotter end to the colder end of an object is known as conduction. What it is known as? It is known as conduction. So what is conduction? Conduction is a process by which heat is transferred from the hotter end to the colder end of an object. Now in solids, how many states of matter are there? As you all know, there are 3 states of matter. What are they? They are solid, liquid and gases. In solids, generally the heat is transferred by the process of conduction. Now the question arises, do all substances conduct heat easily? You must have observed that the metallic pan for cooking has a plastic or wooden handle. Can you lift a hot pan by holding it from the handle without getting hurt? Yes. Of course. So why? Now, see, we will do one more activity here. Heat water in a small pan or a beaker. Collect some articles such as a steel spoon, plastic scale, pencil and divider. Then what you have to do? you had to dip one end of each of these articles. What articles you have taken? You have taken 4 articles: a steel spoon, plastic scale, pencil and divider. And then you have to dip one end of each of these articles in hot water. Wait for a few minutes. Touch the other end. What you will observe? You will observe, in case of steel spoon, the other end will be hot, right? Whereas in case of plastic scale, if you will touch the other end, it will not be as hot. Pencil, you will not feel hot. Divider, you will feel hot. So what we can conclude from this? We can conclude from this that material with which the article is made, like if it is made of metal, then on the other hand, like spoon, steel spoon, it is of metal. Divider, it is of metals. So in both the case, we feel hot at the other hand. So we can conclude from it that the metal, in case of metal object, the heat is transferred to the other end, whereas in plastic scale and pencil, we have not felt cold. So the material which allow heat to pass through them easily are conductors of heat. What they are called? They are called as conductors of heat. For example, aluminium, iron and copper. Whereas the materials which do not allow heat to pass through them easily are poor conductor of heat, such as plastic and wood. Poor conductors are known as insulators. So have we got the difference between conductors and insulators? What is it? The conductors are the materials which allow heat to pass through them, whereas insulators are the material which do not allow the heat to pass through them easily. The water and air are poor conductors of heat. Then how does the heat transfer take place in these substances? We will find out this by a small activity. For this activity, take a round bottom flask. Now if flask is not available, a beaker can be used, right? Place it on a tripod or make sure arrangement to place the flask in such a way that you can heat it by placing a candle below it. Wait till the water in the flask is still. Place a crystal of potassium permanganate at the bottom of the flask gently using a straw. Now heat the water by placing the candle just below the crystal. What you will observe? You will observe when water is heated, the water near the flame gets hot. Hot water rises up. The cold water from the sides moves downwards, the source of heat. This water also gets hot and rises. The water from the sides moves down. This process continues till the whole water gets heated. This mode of heat transfer is known as convection. How does the heat travel in air? In which direction does the smoke go? The air near the heat source gets hot and rises. The air from the sides comes in to take its place. In this way, the air gets heated. For this, we'll do one activity. Light a candle, keep one hand above the flame and one hand on the side of the flame. Do your hands feel equally hot? If not, which hand feels hotter and why? Notice that towards the top, the air gets heated by convection. Therefore, the hand above the flame feels hot. On the side, however, there is no convection and air does not feel as hot as at the top. The people living in the coastal areas experience an interesting phenomenon. What is it? During the day, the land gets heated faster than the water. The air over the land becomes hotter and rises up. The cooler air from the sea rushes in towards the land to take its place. The warm air from the land moves towards the sea to complete the cycle. The air from the sea is called the sea breeze. To receive the cooler sea breeze, the windows of the house in coastal areas are made to face the sea. At night, it is exactly the reverse. The water cools down more slowly than the land. So, the cooler air from the land moves towards the sea. This is called the land breeze. You can see on the screen the phenomena. This phenomena is showing. When we come out in the sun, we feel warm. How does the heat from the sun reach us? It cannot reach us by conduction or convection, as there is no medium such as air in most part of the space between the earth and the sun. From the sun, the heat comes to us by another process known as radiation. What it is called? Radiation. Minimum, how much time does it take to reach on the earth? Sunlight, how much time does it take? It takes 8 minutes to reach on the earth. The transfer of heat by radiation does not require any medium, like we have seen in the conduction and the convection. It can take place whether a medium is present or not. When we sit in front of a room heater, we get heat by this process. Even when you touch a hot utensils kept away from the flame cools down as it transfers heat to the surrounding by radiation. Our body too gives heat to the surrounding and receives heat from it by radiation. All hot bodies radiate heat. When this heat falls on some object, a part of it is reflected, a part is absorbed, and a part may be transmitted. The temperature of the object increases due to the absorbed part of the heat. Why are you advised to use an umbrella when you go out in the sun? So that it will save you from the radiation of the sun. You will not get the radiation of the sun as it is harmful for our skin. This is all about the heat and the transfer of heat. Heat is a form of energy. The transfer of heat takes place by three phenomena. What are they? Conduction, convection, and radiation. Now quickly we will revise what we have studied today. The heat flows from a body at a higher temperature to a body at a lower temperature. There are three ways in which heat can flow from one object to another. These are conduction, convection, and radiation. In solids, generally, the heat is transferred by conduction. The materials which allow the heat to pass is known as good conductor of heat, whereas the materials which do not allow the heat to pass through it easily are known as insulators. In liquid and gases, the heat is transferred by convection. No medium is required for transfer of heat by radiation. So now you all have understood that heat can be transferred from one place to another by three methods: conduction in solids, convection of fluids, liquid or gases, and radiation through anything that will allow radiation to pass. The method used to transfer heat is usually the one that is most efficient. If there is a temperature difference in a system, heat will always move from higher to lower temperatures. Then conduction occurs when two objects at different temperatures are in contact with each other. Heat flows from the warmer to the cooler object until they are both at the same temperature. Conduction is the movement of heat through a substance by the collision of molecules. At the place where the two objects touch, the faster moving molecules of the warmer object collide with the slower moving molecule of the cooler object. As they collide, the faster molecule give up some of their energy to the slower molecule. The slower molecules gain more thermal energy and collide with other molecules in the cooler object. This process continues until heat energy from the warmer object spreads throughout the cooler object. Some substances conduct heat more easily than others. Solids are better conductor than liquid, and liquids are better conductor than gases. Metals are very good conductors of heat, while air is very poor conductor of heat. You experience heat transfer by conduction whenever you touch something that is hotter or colder than your skin. Example, when you wash your hands in warm or cold water. The next, convection in liquid and gases. Convection is usually the most efficient way to transfer heat. Convection occurs when warmer air of a liquid or gas rises to cooler areas in the liquid or gas. As this happens, cooler liquid or gas takes the place of the warmer areas which have risen higher. This cycle results in a continuous circulation pattern and heat is transferred to cooler areas. You see convection when you boil water in a pan. The bubbles of water that rise are the hotter parts of the water rising to the cooler areas of water at the top of the pan. You have probably heard the expression hot air rises and cool air falls to take its place. This is a description of convection in our atmosphere. Heat energy is transferred by the circulation of the air. Then the last is radiation. Both conduction and convection require matter to transfer heat. Radiation is a method of heat transfer that does not rely upon any contact between the heat source and the heated object. For example, we feel heat from the sun even though we are not touching it. Heat can be transmitted through empty space by thermal radiation. Radiation is a form of energy transport consisting of electromagnetic waves traveling at the speed of light that you will learn in the higher classes. That's all about the today's session. Thank you.
When we observe what we call fire, we have this combustion reaction going on, and then we see these flames. What we're really observing are the three forms of thermal energy transfer. We're observing conduction, conduction, convection, and thermal radiation all at the same time. So it is thermal radiation. And I could say thermal conduction, thermal convection, and thermal radiation. The word thermal is just relating to things dealing with temperature. So what is the conduction going on? Well, what we have going on in the fuel for our fire, so down here, the fuel for our fire, we have our classic combustion reaction. And I encourage you to watch the video on that in our chemistry playlist or our chemistry section if you're interested in it. But you're taking carbon molecules and their bonds, and then in the presence of oxygen and some heat, you have a combustion reaction producing carbon dioxide and producing water, and even more energy than you put into it. So it's producing a lot of energy. And that energy is going to excite the molecules that are around it. So you have these molecules that end up getting a lot of kinetic energy. And remember, temperature is proportional to average kinetic energy. And so the ones that just combusted, or the molecules right near the reaction, or maybe the ones that were part of the reaction, they're going to have this really high average kinetic energy, because all of this energy was released from that combustion reaction. And then they're going to bump into other molecules that might not have quite as high kinetic energy, but then they're going to transfer that kinetic energy through these collisions. And we have a whole video on thermal conduction, but that's what's happening. Things with higher kinetic energy are bumping into things with lower kinetic energy and transferring some of that kinetic energy, and they're transferring some of that momentum. So that is definitely happening when we look at a fire like this, that neighboring molecules are bumping into other molecules and transferring energy. Now, convection, this is around the idea that hot air is less dense. And it's so if we have a bunch of air particles here, so let's say this is the cool air up here, and it makes sense why cool air is going to be more dense than hot air. Because hot air, these particles have a much higher kinetic energy. And so they're going to bump into each other, and they're going to push each other much further away and get more separation from each other because of that high average kinetic energy. But because the hot area is less dense, this area right over here is less dense than the white area. These might all be the same molecule. I just made them in different colors to show the less dense area and the more dense area. It is going to rise. It is going to rise, or you could even think of it as the more dense area. The more dense area is going to fall around it. Or try to go under it, because it is more dense, and then the less dense area is going to rise. And by doing that, you have the hotter molecules are moving upwards, and then the cold molecules can go down to maybe the source of energy right over here to get heated up more. So this right over here, so hot air rises. Let me write this. The hot air rises. And one way to think about it, makes room for the cooled air to come down and then get heated up again. And that's what's going on in the fire here. You see the combustion reaction. Combustion reaction occurs right over there. Let me do this in a different color. Combustion reaction is occurring in the fuel. The super hot air, it's going to rise. And that's why it looks like these flames are they're moving upwards. They're kind of flickering upwards. And you'll also see, and actually we're going to talk about this in thermal radiation, is that they also change color as they move upwards. But this whole idea of fire moving upwards and the hot air, if you put your hand up here, it's going to be much hotter than if you were to put your hand, say, right here. Even though in theory this is closer to the flame than up here, and that's because the hot air is rising, and it's making room for cold air, or cooler air, I guess I could say, come down here and be part and get heated up again, and then it would rise up again. And so this convection, this idea of the hot air rising or the cold air falling, this is another form of heat transfer. Now, the last form that we're observing when we're looking at fire is thermal radiation. And this is all around the idea that if you have charged particles being accelerated, they're going to release electromagnetic radiation. And so you might say, wait, charged particles, where are those being accelerated here? Well, we have these molecules that are constantly being accelerated as they bump into each other. One's going to transfer kinetic energy from, let's say this one bumps into that, it's going to accelerate that in a different direction. And even this one might go in another direction. And acceleration is a change in velocity. So it could be the magnitude of velocity or your direction of velocity. So as they're colliding, you have all of these acceleration of charged particles. So let me write this down. You have acceleration of charged particles, and then that releases electromagnetic radiation. I know what you're thinking. Wait, hold on a second, Sal. Okay, I can buy that we have molecules that are being accelerated, but where are you getting this charged particles business? Well, we have to remember these molecules are made up of atoms, and atoms are made up of charged particles. They're made up of protons and electrons. And so as you accelerate these, and the more that you accelerate these, the more radiation you are going to release. And you might say, wait, okay, you said I'm observing that in fire. Where am I observing radiation? Well, just the very fact that you can see the fire, the light emitted from the fire, that is electromagnetic radiation. It's just the electromagnetic radiation in the wavelengths that your eye considers to be visible light, or that your eye considers to be light. Even the particles up here, that are still quite hot, they are also emitting electromagnetic radiation because they're all bumping into each other, and their electrons and their protons are all getting accelerated in different ways. They're also releasing electromagnetic radiation, but it is at a slower wavelength than your eye is capable of perceiving as light. If you had an infrared camera, you would see the flames being much larger. You would see them go all the way up here. And if you were to look at the flame closely, you would see down here, right where the combustion reaction is happening, the flame looks blue. And that's because the blue light is higher energy light. And that's because the particles are being accelerated more down here. And then it goes from blue to kind of white, to a yellow, to a red, or to an orange, to a red. And then to your regular eyes, it disappears. But everything that has some temperature is releasing electromagnetic radiation. And you're like, okay, well, that's all fine. I can see it. But how is that a form of energy transfer? Well, if you've ever sat next to a flame, you will feel the heat. In fact, even if the air between you and the flame is cold, you would still feel like you're getting warm. So if this is a flame right over here, so that is fire. And let's say you have cold air. Let's say you're at a campfire right over here. Maybe it's 30. This air right over here is 30 degrees. If you are standing right over here, you would still feel heat. You would still feel like you're getting warmed up. And that's because that electromagnetic radiation is being emitted from the air particles that we perceive as fire, and then that can actually excite particles on your skin, and it'll transfer energy to your skin, and so you feel like you are actually getting warmed up. I remember once, this is kind of a strange story, but I was on the highway, and there was a car on fire, and I was literally, we drove to the far lane because it was on fire. We're 3 lanes away from it, and it kind of exploded. I don't think anyone was in it. Hopefully no one was in it. But I remember right when it exploded, it was an intense, immediate heat that we felt through the window of the car. And that was electromagnetic radiation. That was thermal radiation being released by these accelerated particles in the air around that explosion, which we perceived as an explosion or fire, but then it was warming up particles on my skin.